Hey guys, welcome to the NCEA Level 1 Tables, Equations and Graphs exam paper from 2020. So if you're joining us for the first time, the way this video works is I go through each question, explain to you guys what you need to do for achieve merit and excellence. The best way to do this particular paper, or if you're watching this video, is to pause at the start of each question, have a go at the question by yourself, and then kind of have a look at my answer just to see how I work them out. Now understand that there is so many ways of trying to solve these questions, so my way is not the only way. If you have one that actually gives you the answer and you're happy with it, then stick with it. The other thing that I'm also going to mention is that a graphics calculator is highly recommended for this particular exam. It just makes things so much more easier. And also, I am going to be using the graphics calculator to show you guys the things. Yeah, like I said, it is something that is quite useful for this particular paper. So without further ado, let's get started. So the other thing I'm going to be using as well is we'll be using Desmos, and also I'll show you guys the answer schedule as well, just to kind of make sense with this particular paper. Okay, so let's get started with the first question. Starting off with question 1A, really lovely question to start the exam paper with, because you've got a straight line and you've been asked to find the equation of the graph. Now, if you do know how to do this in the graphics calculator, go ahead and have a go at it. If you are, you still have to figure out a couple of points. So the first point I'm going to take here is 1, 7. And then the second point I'm going to take here is, what is that going to be, 3 and 1. And like I said, as I said to you guys before, I'm going to be using the graphics calculator. So go into stat mode and just put in those two values. So you've got 1 and 7, 3 and 1. There should be instructions for how to do this in my graphics calculator playlist as well, guys, so have a look through it. So what do we got? We've got these 2 points here, and we're going to click on graph 1, calc, and we wanted x, which is your equation of a straight line. So what we've got here is the a value, it says is -3, which is the same as the gradient, and the b value is 10. That's the y-intercept right there. So you just kind of copy that y equals ax plus b. This is something I do recommend people to do. Copy it down like this, and then just go back, have a look at what your a and b value is, and you can actually replace the a with -3 and replace the b with +10. This question is worth and achieved. It doesn't say anything about using any method, so if you have a graphics calculator, you can use it, or you could use the long method, which is finding the gradient and then putting y equals mx plus c and trying to work that out as well. Cool, so that's 1A. Okay, so I am hoping that you'd pause this question right about now and read through it. Cool. So basically what they're asking in this question for the first part, I mean, just to give you a bit of a context, you got these 3 guys that are saving money, and I guess we're looking at the first guy, which is Anaru, and we are trying to figure out how much money he put into his savings plan at the start. All right. One of the things that is really useful when you're doing these types of questions is when you see the words like initial, at the start, beginning maybe, just remember that t is equal to 0. So all we're really doing is we're going to take this equation right here, and we're going to put it down first, and we're going to put down t is equal to 0. All right. So 1.3 to the power of 0 is just 1. So we're going to get s is equal to 50 times 1, which is just 50. So at this point, how much money? So you could put a $sign in there. So s is $50. And that's basically it for this question. All right, so you get an achieved for this question. It does say that units are not required. Just show you guys what the answer schedule actually says. So as you guys can see, it does say that units are not required. So you can just put it as 50 and you should be good to go. All right, so let's go to the second part of the question. So with the second part of the question, what we have is we've got our second person here. Now he puts $50 into the box at the start, so that's something to remember. And then he puts an extra 40 into the shoebox at the end of each year. All right. So you can do it kind of two ways. You could actually create a little table if you want. So you could do something like this. You could put T and then put it as savings. So when it's 0, it's going to be 50. When it's 1, it's going to be 90. When it's 2, it's going to be 130, and so on. Or if you are like, actually, I know that this is because he's putting extra 40 every week, it's going to be looking like 40T. And because he started with $50 at the start, we can write it as 40T plus 50. Now, really important that we just having a look. Oh no, actually no. The answer schedule actually says 40x plus 5 is plus 50 is fine as well. So I would just put like savings of I don't know, Barman savings or something like that. Barman savings is 40T plus 50. Looking at the schedule, yeah, I'll show you guys what I mean. This is one of those papers where we've had like so many different things happening. As you guys can see, they say 50 plus 40T is fine, or they also say 40x plus 50 is fine as well. Now, if you were to give just the gradient, which is 40, or the constant 50, then you're going to get an achieve. But if you get the correct equation, you're going to end up with a merit. So in this question here, just getting this equation is going to get us a merit straight away. And again, like if you are to use a graphics calculator, you could potentially put these two values inside the graphics calculator and actually work out the graph again. I'm just going to do it real quickly, guys, because it's 0 and 1, and we've got 50 and 90. So I'm going to do the same thing, graph, calc, and x, and as you can see, you've got 40x plus 50. So pretty much onto it, that one. Okay, so let's go to the next question. So one annoying thing about this particular paper is that you get such big questions and spaces like always weird everywhere. Okay, so let's have a look at this particular question here. So we've got Kale's savings plan right now, and he's already started with $100. And that's what we've got, and we've been asked to find the equation that represents the savings plan. So one thing is you got to try and figure out first if this is a linear, this is exponential, or this is a quadratic. And this is something that does work. What I generally tell folks is that, you know, if you want to find whether this equation, if this equation is linear, then just take the y values and subtract one from the other. And if they're the same, then it's a linear equation. So in this case, if I go 133.1 minus 121, it's give me 12.1, and then 121 minus 110 is 11. So you can kind of see that it's not actually increasing at a constant rate. So this is where you go, well, it's not linear because when I subtract those y values, it's not the same. So we've got either this equation is a quadratic or an exponential. Now, I would actually say try and do the exponential one. To do the exponential one, what you got to do is you got to take the y values and divide them. So I'm going to go 133.10 divided by 121, and then I'm going to take 121 divided by 110. Now, as you guys can see, we're getting 1.1 here. Now that's how much the numbers are actually increasing by. Like, so it's a ratio that's being increased by. So that kind of should give you an indication that you're actually working with an exponential equation. Remember that with quadratic, your second difference is the same. But in this case, this is how a quick way to check whether this equation is going to be quadratic, linear, or exponential. Okay, so with exponential, and again, your teachers might have taught you this completely different. I know that the one that I've been using is y equals to ART. And again, you guys, like you might have had a different one. That's absolutely fine, right? So it's no biggie there. There is a video of this to show you guys how to calculate an exponential equation. So if you just look it up on my channel, finding exponential equation given 3 points, you'll find a video and you should be able to work this out. But I am going to show you with this particular one some kind of like easy little tricks here. Now, the good thing is we already have figured out what R is. R is actually equal to 1.1. So we know that R is equal to 1.1 from the calculator that I just show you the kind of like the working out there. So we can rewrite this as y is equal to a times 1.1 to the power of t. Now the one other thing that we also know is we also know that when t equals to 1, s is equal to 110. So in fact, I'm going to work with that s and t rather than y. So let me just get rid of the y, and I'm going to replace it with the s here. All right, because remember that this is x and y right there. So now that I've got that, I know that when t equals to 1, s is equal to 110. So I'm going to replace 110 equals a times 1.1 to the power of 1, because t is equal to 1. Then I can say that a is equal to 110 divided by 1.1. And therefore a is equal to, I got to go 110 divided by 1.1 gives me 100. So the equation that I have is actually equal to 100 times 1.1 to the power of t. Now, did I really need to do all of that working? Theoretically, no. Why? Because if you guys have a look at the question, right there at the top, it actually says Kale already has $100 in his bank account at the start. So that means when t is equal to 0, so if I was to take this table and go one more step back, t is equal to 0, that's actually 100 there. Now, in exponential equations, all right, this is something that it's worth remembering. The a value is when t is equal to 0, okay? And the reason is because if we actually go y is equal to ar to the power of 0, r to the power of 0 is 1, so we're just going to get y equals to a. So in exponential curves, whenever you're dealing with the starting value, that generally is the a value. So, and I've just shown you like a couple of different ways of kind of getting to that equation. So grades wise, what are we looking at? Correct equation for Kale's saving plans gets you a merit. A value of 100 identified or 1.1 identified somewhere gets you, yeah, so either getting one of these two values is going to get you an achieved. Otherwise, the final equation gets you a merit. All right, what do we got next? And I'm not going to enjoy this next question because it's just an ugly question. All right, so our last part of this question with question 1 is we've got a fourth person now coming along. The graph on the next page shows Delhi's saving plans. Okay, so there we go. That's Delhi's saving plans. It is a quadratic. How many graphs do we have? We've got Kale, which is an exponential. We've got Barman, and then we've got Anaru. Okay, so we've got 4 guys. That's 4 graphs. Four? No, I think I'm doing something wrong here, but it's all right. All right, guys, so question 4, what we have here is we've got another person coming in, and their equation for their graph is down here, which is a parabola. And it basically says, okay, so here's something that we need to remember. It says use tables, equations, and graphs. All right, which means we have to use graphs and one of tabular equations from the sounds of it. And we've got to compare the amounts saved by Anaru, Kale, Delia. Okay, fine. So what are our equations? we know that Anaru's equation was, who was Anaru? That's the first guy. Yeah, 50 times 1.3t, that's the first guy. Then we've got Kale, which we figured out last time, was it? Was that Kale? Yep, that's 100 times 1.1t. And then now we've got Delhi, who is 10 times t minus 2 squared plus 40. So as you guys can see, these the graphs, these are the three graphs that we're looking at, okay? Now, it does say use tables, equations, and graphs. Now, if I look at the graph part of it, it's, to try and sketch the graph straight away, it's a bit tricky, right? Because, you gotta have some points. So I guess that's why it's good to actually go and get the table first. And what we're also looking for is the first 9 years. So I'm literally going to create a table right underneath like this. And it is going to be a pain, but I'm trying to think of another way of doing this. I think I might have one. Let me just see if this is going to work. Check this on the calculator. So, I mean, I know I said at the start of the session that, having a graphics calculator is extremely handy. And I guess this is one of those reasons where the graphics calculator comes handy. For you guys, you're lucky in the sense that where Dale's diagram is already done there. Oh, it's not Dale, Delhi's. Jeez, what kind of name is that? But we still got to work out Anaru's and Kale's values. And, if you had a normal, like if you were going to do this normally, what you would do is you would go into menu and you would type in the value 50 times 1.3 to the power of 1, 65, and then you would do it again, and this time instead of 1 you would put it as 2. Oh no, sorry, wrong one. 84.5. And as you guys can see, this is going to take a bit of a long time to try and work this all out. And I guess that's why I mentioned earlier about the graphics calculator and its uses. So what you do is you go down to the menu that says table. That's menu number 7. You click on it, and right now you've got space for 3 functions. And I'm going to put those 3 functions. I'm going to put 50 times 1.3 to the power of, instead of t, I'm going to put this little x right here. That's my first one. My second one is 100 multiplied by 1.1 to the power of x. And then my next equation, Delhi's one, I'm going to put it anyway. So it's going to be 10 times x minus 2 squared plus 40. So that's basically my 3 equations. Now, there's another thing called here, something called set. So I can actually set the table where I say the starting point is 1 and I want the end point to be 9. Press enter, press exe again, and then I can press enter again. And as you guys can see, this just spits out all of those values that you want. All right, and so now all I'm going to do is, as I said, being extremely lazy. What do you got? 65, 110, 50. All right, guys. Yeah, that was a bit of a speed ride right there, but basically what I've given is the table of those 3 guys for up to 9 years. All right. Now, what we next need to do is sketch a rough graph. Now, I'm going to choose a couple of different colors so you guys can actually see. Anaru is going to be A, and this is where I am going to kind of start losing the plot with this because I need to try and zoom in and kind of get a rough sketch. So basically what you're trying to do is like at 1 it's 65, so somewhere there. At 0 I think it was at 50. What else we got? 109. Yeah, this is just not fun. As you said, I'm not doing like a perfect job here. I'm just kind of like roughshotting it. 530 is somewhere there. Yeah, so for you guys, I would actually say that you probably need to just plot those points correctly. I know it's kind of hard for me to do it in this particular one, and then Kale is starting at 110. No, he starts at 100 first. Then he goes to 110 up to 235. It was somewhere here. Yeah, it's just a terrible graph, but you guys get the idea, right? So what you guys need to do is like plot those points and then just join them up into one smooth curve. Cool. So what is the question actually asking? It's just saying the question is actually asking about compare the amount saved by Anaru. Now, if you guys have a look at these particular graphs, now something is happening at certain points of that are quite important for us. The first one is right here. Maybe I should use a different color. Actually, I'm going to use this. So the first point is right there when Anaru's one is overtaking. And then my second point is there, and then the third point of interest is around there. So I actually need to find out those 3 points, right? And I guess the best way to do that is you have to use your graphics calculator again. So we're going to go into graphs. And so see how you got those 3 graphs there? I am just going to draw it, and yep, I'm going to get one of those. That's fine. I'll see if I can try and fix that. I don't know why, but it's making me type the whole thing again. It might be the same for you guys. X, enter, and then 10 times x minus 2 squared plus 40. Now, the problem is, as you can see, I can't really see the graph, and that's because the view window is so tiny. So I need to change the y-axis and the x-axis, right? So I'm going to change that by clicking on Shift F3. And my x minimum, I'm going to put that as 0. My x maximum, I'm going to put that as 9. And then my y minimum, I'm going to put it as 0. And my maximum is 550. Let's do 550. And then draw again. There you go. There's my 3 graphs. Now notice how there's like 3 points that are quite important for us. That's where the intersection is happening. Now you should be able to find the intersection. Yeah. So it's asking which one and which one. I'm going to go that one and that one. So there's my first point, which is 4.4. At 148. That just shows how bad my graph is. See, this is what happens when you sketch the graph. Hopefully you guys are much better artists than I am. Yeah, but can we check that in up here? So we've got something happening. So I'm just going to draw a rough sketch here, just so that we can kind of get an idea. So we got the black one, which is Delhi, that goes something like this. The blue one, something like that, and the red one, yeah, something like this, right? So what I know is that the first point of interest is at 4.14 years, and then my second point of interest between Y3 and Y2, so that's at 5.61. That's much better in my real graph. And then intersect between Y2 and Y3. No, I already did that. Y1 and Y3. That's 0.624. All right, guys, now this type of question, and I know you guys can look in my graph and you can kind of see that like I just kind of rushed it. That's why my values were not as correct in the graph itself. But hopefully when you guys draw the graphs, like you're a little bit more accurate with drawing it, which means you probably get a much better estimation than what I did. Now, in terms of the answer itself, I'm actually going to share you guys the exam schedule because it's just one of those questions where it's hard to explain, and when you kind of see the answer schedule, it starts to actually make a bit of sense. So, if you have a look at it, the very first thing that we need to kind of remember is that have we produced graph of Anuru's saving plan produced? Yes, we have. That's the graph there. Have you got a table of it? Yes, we do. So we've got two of those things, which means a complete table and graph with one. Okay, so complete table and or a graph with all three plans, and if no comments are given, you're going to get an achieved. So right now, what we're looking at is just an achieved because all we did was the table and we did some graphs. So we need to have two valid comparisons to get an excellence with referencing all three saving plans. With referencing from table for A to C and D and wow. Okay. And I guess that's why we kind of have to go back and have a look at our values. If you look at our time, you know how we found those three times, 0.625, 4.1, and 5.6? All you're saying is who's actually got the most money. So if I go back to my graph, trying to find the mouse, hang on. There we go. So basically what you need to say is, I think this was Anuru, Delhi. And then who was the last one? Kale. So you kind of want to start off by saying that, when at the beginning, Kale had the most money, and then your second point could be like at 0.624, 6 to 5 years, Anaru and Delhi had the same amount of money. Then at 4.41 years, Kale and Anaru roughly had the same money, but then Delhi had a lot less. Then you could say something like at 5.61 years, Delhi actually had the same amount of money as Kale, but then Anaru had actually got more money. And then eventually you can kind of say that Anaru and Delhi increase the money, but then Kale just is kind of slowing down as time goes on. So you got a lot of different things that you can talk about. But yeah, like I said, going back to that schedule, you can make any one of those 1, 2, 3, 4, 5 comments that are there, sample comments. Where I think that for excellence, you're just looking for two valid comparisons with reference to all the points and the graphs. Yeah, so one of the main reasons I hate tables, equations, and graphs is because of these long-winded worded questions. And if you make a little mistakes here and there, obviously look at this, you got allow consistent errors as well. So yeah, it's just one of those questions where you just kind of write to your heart's content. Cool, guys, that's basically it for question 1. All right, guys, so we're going on to question 2. Now, question 2, nice little sketch the graph. We're going to go straight into the calculator to get our points like we did with the table function. So what we could do is just go into table, just get rid of all of this. It's amazing that we still get to use this calculator of all things. So we've got x squared plus 2x minus 8. And I'm going to set the table. This time I'm going to set the table. See how it's going from 1 to 5? I'm going to set it from -6 to +6. I think that should be good. So let's go -6 as starting point, +6 as the end point, and let's create the table. Okay, so at -6 it's at 16. Don't really care. At -5 it's at +7. -4 it's at 0. -3, -5. 3, -5. And I think after that we're pretty much -2, -8. Oh yeah, here we go. Now it starts coming back. So 3A is 37. Yep, 416. Okay, so good thing about this, getting all those points, and then once we get all the points, we draw a smooth curve showing intercept with axes and minimum point. Intercept with axes. So we want to make sure we get a nice smooth curve going through. So much harder to draw this on a tablet, but there we go. That's basically it. That should get you guys an achieved. Cool. Next question. So the next question, what we've got is blah, 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 blah. Hopefully you guys went through that. It's saying how much higher than the top of the net will the ball be when it passes over? So we're actually looking for this distance here, the green part, not from the ground up to the red line, but the green part. So at that point, we can say that x is equal to 0. So we're going to substitute h is equal to negative 0.2, 0 plus 2, 0 minus 8. We're going to get negative 0.2 multiplied by 2 minus 8, which is going to give us 3.2. Now the 3.2, just remember that the 3.2 is actually the distance from there to the ground. And we're actually looking for higher than top of the net. So we've actually got to go 3.2 minus 2.4 to get 0.8 meters above the net. And it's really important we write that above the net sentence, and we also write the 0.8. Units, not so much, they're not fussed about it. But yeah, to get a full to get an achieved, you've got to make sure you do that 0.8 part. On to the next question. Now this question here, guys, it's one of those statement questions again. Now I'm not sure if this is the picture that was used in the exam, because that was what I found in the exam paper, and I tried to follow the link, and in that link there was heaps of pictures. I thought this kind of try to make sense. What I'm actually going to do for this particular one is I am actually going to show you guys on Desmos what the effect of it could look like. All right. So first off, I'm going to kind of get this graph. Where is it? Let's just get this equation first, and then I'm going to show you guys what it looks like. Give me 1 second. All right, so what I'm going to show you guys is I've just kind of translated this graph in Desmos just to give you a bit of an idea. So what we've got here is the net, and we've got the graph that actually looks like this. So this is the graph that we originally had. So if you guys have a look at, where is it? So the H right there. This is the graph. I've simply taken the graph and I have drawn it on Desmos. Now the question is asking is what can we change so that the person doesn't actually block it, right? So the first thing I'm going to talk about is this little value here, which is generally known as like the scale factor. Sometimes it's called the A value, you know, lots of different things. So I'm just going to put that as A for now. And I'm going to change that to negative 0.2. So this is what the graph looked like, right? But what happens is if I drop the A value, then potentially the person could not block it because the ball's going to go really, really high. So if the A value is less than negative 0.2, then the ball is going to go high, and which means the girl can't actually block it. All right. So that is one of the reasons. So changing the scale factor from what it was before, which was negative 0.2, and then changing it to negative 0.3 or anything higher than that. The other thing is if you actually make it to 0.1, then what happens is it's actually going to hit the net because that blue line is where the net is, and it's going to go below the net. So we don't want it to be at 0.1. Where is it? Yeah, that's 0.1 is going to actually hit the net. 0.2 goes over the net. 0.3, it's probably not going to get blocked out. So there's a couple of valid points right there. The other thing also worth noticing is that for the graph, if you have a look at these two values, so right now we're getting those two, -2 is from there, +8 is from there. Now the halfway point between 2 and -8 is actually 3, and if you substitute 3 in this equation, you should get 5. So this is where the highest point of the volleyball is. So what we could do is we could actually shift the entire graph 2 units to the left. So that means I can change this from 2 to 4, and this one from 8 to 6. And what I've literally done there is I've just shifted the graph 2 units to the left. Maybe what I'll do is, so this is the original graph, right? And then I'm going to draw a second graph. So as you guys can see, I'm still keeping the scale factor the same, but I've actually shifted the graph by 2 units to the left. And by shifting it 2 units to the left, I can safely assume that there's no way this shot is going to get blocked, because for someone to, like jump that high to up to 4.8 meters, that's quite a big ask right there. So that's another thing that this person could potentially adjust so that the ball doesn't actually get blocked. So there's 3 points that we talked about. The first point is changing the A value. So if we change the A value from 0.2 to less, then the ball is not going to get blocked. If it goes to 0.1, -0.1, then it's going to hit the net, and we don't want that. And then finally, the third point is like shifting it 2 units to the left, which means changing the equations. Again, that will keep the ball safe as well. So if you have a look at the answer schedule itself, they've kind of given similar kind of answers there, talking about the shift. And then we've got, if it makes -0.1, it'll make the ball go lower, so we want to make it the net. 0.3 will make the go higher over the net. And basically what we're looking for is like 2 valid statements gets you a merit, 1 valid statement gets you an achieved. Okay, hopefully that helps. As I said, tables, equations, and graphs, just a lot of writing. Anyway, moving on to the next question. All right, guys, so question C1, having a look at it, it looks like, I'm just looking through it, it just looks like you just need to get a equation of the path traveled. So just the equation of the graph. Okay, so again, if you want to do this the long method, I think I have a video called the vertex method, finding the equation of the parabola using the vertex method. Check it out, and you should be able to work through that. But I'm looking at this and I'm saying, why can't I use the calculator? So I am going to try and use the calculator. For parabolas, you guys need to get 3 points. And what we're going to do is we're actually going to use symmetry and try and get the 3rd point, because we actually don't have where this ball lands yet. So we're going to use symmetry to try and figure it out. Now the way it works is like this. So this is the halfway point, right? Which is 1.8 and 4.8. So basically, I need to figure out the length of this thing right here. Now I know that from here to here is 3.2, and then from here to here is 1.8. So that's actually 5, which means on the opposite side, I'm actually going to go 5 long for it to be symmetrical, which means this point right here is going to be basically 1.8 plus 5 to give that x value there, which is going to be 6.8 and 2.3. Now I got my 3 of my points. I am straight away going to go into my calculator and punch it in here. So I've got -3.2, 1.8, 6.8, I've got 2.3, 4.8, and 2.3. Go into calc, graph one, calculate, and I'm looking for x squared. And as you guys can see, it's going to give me this equation. And again, you guys can see the a value is negative 0.1, b is 0.36, and c is 4.476. So h is the height. So instead of y, I'm going to use h. And I've got negative 0.1 x squared plus 0.36x plus 4.476. So I'm going to show you guys the answer schedule, and I'm going to tell you guys why we can actually use this from the looks of it. So where is it? So as I said, the vertex method is that you actually you get the vertex and you write the equation and then substitute the values to figure out what the k value is. Now, what we did was we used 3 points and we used the calculator to get the equation, right? So if you guys have a look at this, look at the schedule. So that's where the vertex form was, and then we got this equation right here at the bottom. And what they're also saying is that you get a merit for CAO, which basically means correct answer only. So we've just given a correct answer only, which is also the correct equation for H, which also means we get straight away, we go into merit territory in this case. And if you do want to learn the vertex form, guys, just look up my channel and look for finding equation of parabola using vertex form. There is a lot of examples there for you guys to have a go at. Cool. Okay, so let's have a look at the next question. Unfortunately, I couldn't find the picture for this particular question. I went into their website, but there was just like a hell of a lot of other pictures, and I just didn't know what it was. So I guess we kind of have to try and figure out with the words what the question's actually asking us. So Ruru joins Tane standing on the opposite side of the net. So I think that could be Ruru. Equation of the path traveled by the volleyball is this. Before it hits the ground but misses the ball. Okay, so I'm not sure. Ruru is going to miss the ball. Because Ruru is going to miss the ball, we want to try and figure out what the landing point is. So basically what we're looking for is when h is equal to 0, what is x? So we're just going to substitute h equals to 0 into the main equation. X minus 2.1 squared plus 3.9, and it's just a matter of now rearranging everything. So bring the 3.9 to the left-hand side, it becomes minus 3.9. And we've got negative 0.25 x minus 2.1 squared. Then we've got to divide by negative 0.25. What's that going to give us? All right, so that's giving us 15.6. So we can say that x minus 2.1 squared is equal to 15.6. Then we're going to take square root of 15.6. So x minus 2.1 equals square root of 15.6, which is... Now, this part is important, guys. We make sure we put the plus or minus 3.9. There we go, 3.95. Then we can say that x is equal to 2.1. I need to move that. So 2.1 plus or minus 3.95. So my first answer is going to be 2.1 minus 3.95. And my second answer is going to be 2.1 plus 3.95. So in this case, we've got 6.05. And then the other end, I've got negative 1.85. Now, I can ignore negative 1.85 because this is where negative 1.85 is going to be, because that's the shape of the parabola. And then this is going to be 6.05. Now, looking at this question, it does say use equation or graphs. We've actually decided to do it with equation, and we've got a very rough, ugly looking graph there. So basically at this point, we're going to say that ball will land 6.505 meters from the net. So just trying to look at it seems like you can actually, I'll show you guys the answer schedule. So this is the method that we did, right? So we actually went 0 and then we got 6.05 meters. So grades wise, putting the equation equal to 0, just putting it equal to 0 gets you an achieved. Wow, that is just unbelievable. That first line gets you an achieved straight away. Then what have we got? Graph attempted, we didn't do that. We did reaching the stage of this, which is square root of 15.6, which gives you a merit. So if you go back here, I think somewhere here is going to give us a merit. Obviously getting the final answer is going to give us an excellence. And what are the things? Find the correct value, accept use of graphic calculator. Okay, so I will show you guys how to do the graphic calculator version as well, because it looks like you can actually do it from just graph simplification to the quadratic. Well, you don't need to do that in a graphics calculator. Cool. So as you guys can see, there's like quite a few different ways, and I mean, if you sketch the graph, you can do a rough sketch, and you can get an approximate of 6, but then it has to be from the graph, so you can't just like guess and check. Okay, so let's have a look at this, and I'm going to show you guys how to do this on the graphics calculator. So what we can do is we can go into graph mode, and we're going to put this graph in here. So we're going to get negative 0.25 bracket x minus 2.1 squared plus 3.9. So this is my graph right now, and I'm going to draw it, and I'm going to click on Gsolve, and I'm looking for roots. So roots are basically just your x-intercepts and your y-intercepts. So if you can look at it, that's the first one, negative 1.85, and then you click on the arrow, the next one is 6.05. So you can put that equation straight into the graphics calculator, the graphs mode, and get those two values and put that on, because yeah, that'll get you only an achieved by the looks of it, because I'm just trying to look at here. So correct answer only gets you an achieved, so that's a 6.05. But finding the correct value of x with clear justification and evidence, yeah, I guess, you know, if they ask for that, then you're going to have to show some sort of working to get a full excellence grade. Okay, we go to the next question, if it loads. Now, that was basically it for that question, guys. We go to question 3 next. Alright guys, we are up to question 3 now. So with question 3, what we've got is a very quick sketching of the graph. And you know what I'm going to do is I'm going to go into my table function and get the points. Otherwise, it's just, I mean, you can kind of do it straight away as well, but it's all right. So what are you going to go? 3 to the power of x minus 1. Close that. And I'm going to set the table from -2 to +5 and get the table. So you can kind of see at 1, it's going to be at 1, so 1, 1. At 0, it's at like 0.33, so it's kind of got that curve happening right there. At 2, it's going to be at 3. At 3, it's going to be a 9. And at 4, it's going to be a 27. So there is a nice, I'm going to try and get that smooth graph. Might not, but let's see. Good enough. Okay, so those I got my main points there, and that's going to give me an achieved. Going to the next part of the second question here. Now the second part of the question is, sorry, second part of the second question 2b. Well, what we're looking for is we're actually looking for this point right there, because that is where the bird is at the highest point above sea level. And if you look at it, the parabola itself that we have, it kind of looks like this. All right. So if you understood vertex form, this parabola is actually given in vertex form, which means the 2 is right there and the 15 is right there. So the maximum height of this parabola is where the vertex is, and the vertex happens to be at 215, which is basically derived from that parabola that's in vertex form. So basically, because that's at 215, we can just say 15 meters above the sea level. Once again, this question is worth an achieved, and we move on. So I guess this kind of leads up from that next question. Is it's saying find the equation of the bird's path when it follows a straight line diving into from D to S. So we're asked to find the equation of this straight line here for this question here. Now we already got 1 point. Our first point is 4,9. That's where D is. The other thing that's also noticeable is point S, which is right here. S is 10 meters from the base of the cliff. So our second point right now, this point right here, could be said as 10 and 0. So with that in mind, we've got 2 points. So I guess we can just go jump straight into the calculator and chuck in those values. We've got 4 and 10, 9 and 0. And we're going to calculate with x. So here is our equation. Our equation is y is equal to negative 1.5x plus 15. Grades wise, yeah, grades wise, this is a merit question. I guess it's a merit question because you got to actually derive those 10, 0 as a point and then try and work it out. For achieved, you're looking at just the gradient or just the y-intercept calculated. So that could get you an achieved. But otherwise, you end up getting merit for this question. A couple of nice ones to start this set of questions. Okay, let's have a look at this one. All right, guys. So basically for this question, it was very similar to the volleyball question that we did earlier, right? So what we've got to do is we just got to describe what could happen in this other situation if we get another parabola-shaped pathway for this second bird. So what I'm going to do is I'm going to jump over to Desmos just to show you guys some of the things that's happening here. Okay, so the black line that I've got here is the original bird's equation. Now we're not really worried about the second part. I think we're just looking at that first part of the parabola. So that's the only part that I'm working at. So I'm going to show you guys what happens if we change a few things, and that's what you guys need to write about. So the first thing is I'm going to change the negative 1.5. So I'm going to change it to maybe negative 2.5. So when I change it to negative 2.5, what I need to say is the bird's flight path is a lot more steeper, but it still has the same maximum height that it reaches as 215. That's when the value of the scale factor is changed to 2.5. If I change it to 0.5, it's a lot more flatter, but the maximum height it reaches, it's still 2 and 15. So that's what adjusting that scale factor actually does. That's something to remember. The next adjustment that you could do is actually taking that 15. And instead of 15, you could actually make it to 20. And if you were to make that 20, then what happens is the maximum point now is actually shifted up compared to that the first bird's flight path. At the same time, if you make that less than 15, then the maximum height it's going to reach is at 10. So that's some of the that's the vertical changes that you could talk about. And then you can also talk about the horizontal changes. So if this was instead of -2, let's say this was -4, then what would happen is it reaches a maximum height at 15. Still, the maximum height will be the same, but the distance away from the cliff, it's 4 now instead of 2. Likewise, you could actually change that to 1, for example. If you change it to 1, then the maximum height is still reaching at 15, but it's actually 1 meter closer to the cliff than it was. So what they really are asking you guys to do is take that equation, change each of these values, and what is that each change of that value going to result in? That's what they're trying to ask. Because when I looked at the answer schedule, some of the sample comments that they talked about was like adjusting the coefficient, altering the adjusting the coefficient there, or altering the values inside. And of course, the final one is like when you change all three values, which means it leads to a completely different maximum height and leaving the cliff at like different points as well. So as you guys can see, it's like basically worth a merit for 2 statements, and 1 statement is worth achieved. Don't know why. This is what tables, equations, and graphs has become. It's becoming more about elaborating your graphs than actually finding the graphs. So yeah, that's basically what it is for this question. 2 statements gets you a merit and 1 statement gets you an achieved. So moving on to the next question. Now this question here, folks, I know that a few years ago that I did release a video on, I think it was like a 1-hour tutorial on tables, equations, and graphs where we did questions similar to this. It is, how do I say it? It's almost like I call it a cookie cutter question because there is only a certain number of steps that you have to do. And once you get those steps, you pretty much rinse and repeat for any type of these types of questions. Long story short is what you got to do is you got to write an equation for the perimeter. And then using that equation, you find a parabola like you work out an area equation. So what do I mean by that? So let's break this down first, right? So we've got this paddock, that rectangular field of equal size. That means we've got, this is going to be x, 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 and x. And we're going to make this entire length up the top there as y. All right, so if we take the fencing part of it, we've actually got 120 meters. So we can write this as perimeter as 4x plus 2y equals 120. All right, and how do we get that? Well, let's see. We've got 1x, 2x, 3x, 4x, 4x plus 1y and 2y equals 120 meters of fencing. So we basically use all 120 meters of fencing. Now what we can do is we can actually rewrite this statement, like rewrite this, simplify this equation and rewrite it. So we're going to write this as 4x plus, what am I doing? I'm going to write 2y actually. So 2y is equal to 120 minus 4x. And then y is equal to 120 minus 4x. And the whole thing is then divided by 2. So that means what I have is y can be said as 60 minus 2x. So this is my perimeter. Now I need to what it's actually asking us is, once again, they're doing this whole tables, equations, and graphs. So we've actually got to also do a graph for it to find, to investigate the relationship between total area and the length. Yeah, okay, fine. So once we got that, that's a perimeter. Next thing is working out area. Now, if you remember, areas of a rectangle is base times height. So in this case, we're going to get base is equal to y and the height is x. But because we said that y is equal to 60 minus 2x, we're going to replace the y with 60 minus 2x multiplied by x. So what we have is we've got an equation for area, which is x multiplied by 60 minus 2x. Now we need to try and figure out what the maximum area for this is. What we can do is we can actually draw this as a graph, but of course, if we're going to draw this as a graph, we're going to need some points. And I guess this is where your algebra from MCAT actually comes in handy, because what we know is when we expand this, we're going to get 60x minus 2x squared. Now, this is a negative parabola because it's negative 2x squared. We know the shape of the parabola is going to look like this. We also know that there's going to be 2 points where y is equal to 0. So what we are going to do is we're going to take this part right here, put that equal to 0, because we want to find out at what values of x is the area equal to 0. So we're going to put that equals to 0, and we're going to get x and 60 minus 2x. So therefore we can say that x is equal to 0, or 60 minus 2x is equal to 0. Rearranging this, I got negative 2x is equal to negative 60. And then x is equal to negative 60 divided by negative 2, which gives me positive 30. So these are my 2 values, which is going to give me an area of 0. Why is that? Well, let's kind of have a look at this. If I take x as 0, then my y is going to be 60 at the top and 60 at the top, and x is 0, which means I don't really have an area, so it's not going to actually work out. And if I take 30 as x, then my 4 lines are going to be 30, which means 30 plus 30 plus 30 is 120, which means I don't have any fencing left over for the y direction, and therefore once again it becomes 0. So what does this look like in terms of a graph? So what we're going to do is we are going to give a table first, right? So they did ask for a table. So we're going to put down x first and whatever the y is, and then we're going to actually put down the area. Because remember, y is equal to 60 minus 2x, and then area is equal to x times y. So I'm going to go into my calculator, and I'm going to go into table, and I know that I'm going to have to work between 0 and 30. Now, I don't want to be writing down every one of those values down, all right? I don't want to write down like 0 to like 30, that's like 30 numbers. I'm not going to write down 30 numbers. But what I do know is that between 0 and 30, the maximum happens when it's at 15. Because if you think about it like this, your parabola looks like this, where this is 0 and this is 30, and the halfway point is 15. So going up in 5s is a good idea. So I'm going to go into table, and the first thing I'm going to do is I'm going to do 60 minus 2x. And then the second thing I'm going to do is I'm going to do x multiplied by y, which is 60 minus 2x. Chuck that there, and I'm going to click on set. My starting point is going to be 0, and my end value is 30. And I said I want to go up in 5s because I know that 15 is in the middle there. So I'm going to go up in 5s like that, and press enter, and table, and there we go. So I've got 0. Once again, I need to remember to fast forward this section. 0, 5, 10, 15, 20, 25, 30. I've got 60, 50. Cool. So that's my table right there. And of course, I need to draw this as a graph, but I didn't actually, what do I call it? I didn't actually copy a graph paper, but that's okay. Was there one given for you guys? Yes, there was one given for you guys. I just didn't copy it. Apologies. So just going to do a rough sketch here, but you guys obviously will be having the clear grid line, so you should be able to kind of work it out. I'm just doing a rough sketch here right now to show you guys what this graph looks like. So at 0 and 0, 30 is at 0. At 15, it's at 450. So I'm going to get a rough shape like this. And so I can kind of say that max area is when x is equal to 15 and y is equal to 30 and area equals 450 meters squared. I wouldn't bother again with the units, but that's basically what you could do. In terms of grades, a correct value of maximum area with correct and clear, just and full and demonstrated and showing evidence of equations, tables, and graphs. All. Yep. So this is basically gets you an excellence. For a merit, symmetrical table gets you a merit or a graph that could be used to find maximum area, which there. Maximum area found with at least 3 correct areas. So you can do a little guess and check here as well, folks. So you could actually do like 3 experiments. So for example, what do I mean by experiments is like, say, for example, you take x as 10, then that's going to be 10, 20, 30, 40. What's left over is 120, and 120 divided, sorry, what do we got? 120 take away 40 is 80, so 80 divided by 2 is 40 and 40. So this is like an experiment that you can also do for these types of questions instead of doing what I've done. So you could do x equals 10 and then work out that area equals 40 times 10, which is 400. Then you could try like maybe x equals to 20 and then try like x equals to 25 or whatever. You know, it's like you can just give things a go as well that way. Cool. Yeah, so that's basically it for this exam, guys. And I'm not going to lie, like, I always leave tables, equations, this paper to the last because I hate it. I'm not going to lie, I hate it. I hate this paper because it's long to try and explain all of the concepts because it's just so much that's actually packed in this. But yeah, as I said to you guys at the start, I would strongly recommend you guys to get a graphics calculator for this particular exam. It is very, very useful. And yeah, and good luck for your guys' exams. That's all I can say. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.